Good evening, everybody. Good evening, good evening, good evening, my friends. I hope you guys are able to see me and hear me clearly. So, am I audible? Am I visible or not? Tell me. Quickly confirm. Quickly confirm, everybody. Okay, guys. So, as you might have read in the title of the lecture, today what we are going to do? Today we are going to start the basics of control system stability. Okay, that is, I am not directly going to the route criteria. I am going to tell you what we exactly mean by stability and how do we arrive at the stability criteria. Okay. So you will learn the stability from the very basic level. I am not directly going to come and say, guys, that if the poles are lying in the left half plane, then the system is said to be stable. I am not going to do that. I am going to derive everything from the very basic. And as I have told, I'll relate it to the stability that you study in signals and system so that you can relate the concept better. So my friend, if you are watching this video, make sure that you have pressed the like button because that is how you mark your attendance in my batch. And if you are coming on this channel for the first time and watching this video for the first time, okay, watching this video for the first time, then make sure that you subscribe to this channel, press that red button and hit that bell icon so that you can get the amazing free content that we are providing. Okay, the amazing free content that we are providing, you can get the benefit of that. So make sure that you press the subscribe button. And my friend, I have already told the fees of this lecture is the share. So if you click on the share button and share the link with all your friends and colleagues, then you have paid the fees of this session. So I only want one thing from you is to make this channel, is to make this community the biggest community for electrical and electronics engineer, and that can only be done if you keep sharing because sharing is caring. So let's start this session. So let me introduce you myself for those who don't know me yet. My name is Ankit Goel and I got AIR1 in GATE 2014 and 2018 in electrical engineering. I am working as a director at Unacademy for GATE department. And my friend, I have got the President of India gold medal from the President himself in the year 2013 when I graduated from IIT Indore. And till date, I have taught more than 1 lakh students in online and offline mode. So I clearly understand what are your learning needs and I can modulate the content, I can modify the content and present to you in a form which is easily understandable, which you can easily absorb, my friend. So my friend, what we are doing is we have created a revolution. We have created a revolution on YouTube as well as Unacademy, where on YouTube we are providing the maximum amount of content for free, which was not even thought by any other institute or any other company in this country. But yes, Unacademy has made it possible for even the weaker student, weaker section of the society to get the best quality education for free. And my friend, we have also created a revolution on Unacademy where we are providing quality education at the most affordable price. So, can you get a rank without taking subscription? Yes, of course. But do you need to take subscription? Absolutely. Why? Why? Because just by taking free classes, it is not very much possible, or you can say your path will be harder, because if you take the subscription, most of the work will be done by us and you only have to execute whatever we tell you to do. You only have to do that, and once you do that, definitely you can get the best rank in the GATE examination. Is that clear? So at Unacademy, we will be providing you the daily live classes, we will be providing you daily practice questions, we will be providing you test series, we will be providing you practice questions, we will be providing you weekly quizzes on every Sunday, we will be providing you the solution of that weekly quiz in the form of a video, we will be providing you the doubt solving, guidance, everything with just one subscription. And that subscription, my friend, opens up with one code, that is Ankit ESE. Ankit ESE is my code which directly connects you with me and you learn to crack GATE under my guidance. And my friend, even if you don't join Unacademy, make sure that you have the Unacademy learning app, because every day at 1 p.m. I am taking the practice class of signals and system free of cost Monday to Friday on Unacademy. So you need to get that app, you need to download that app, and then only you can take the benefit of the free content. Now my friend, let us start this session. Let us start. So guys, what we are going to learn today? We are going to learn about stability. We are going to learn about stability, my friend. Now, what do you mean by a stable system? What do we mean by stable system? So, देखो, a stable system is the one which after experiencing a disturbance, okay, which after experiencing a disturbance can return to its original state, okay, can return to its original state. So that sort of a system is called as a stable system. This general definition, my friend, this general definition works for each and every system. When a system is disturbed from original state and it comes back to original state, okay, to original state, it is said to be stable. It is said to be stable, my friend. Okay? That is the basic definition of stability that works well for each and every system. It works well for every system. You just have to remember the basic nature of a stable system. A system is only stable if it tries to remain in that state. Any state can be stable if a system wants to stay in that. But if a system does not wish to stay in that state, you cannot call it as a stable state. But now, my friend, the definition that we study in LTI system, in signals and system, the definition of stability that we study, that is, if I talk about stability of LTI system, okay, because the systems that we study under control system are all linear time invariant. We don't talk about non-linear system. But yes, under your state variable analysis, you can talk about time variant system. But with transfer function approach, we only talk about LTI system. So what is the stability of an LTI system? It says that if the system produces bounded output for every bounded input, system is said to be stable. Now you might be thinking, those who have not read control signals and system, those who have not studied signals yet, they might be thinking, sir, what is a bounded input or what is a bounded signal? Okay. What is a bounded input and what is a bounded signal? And my friend, don't worry about the notes. I am going to share the PDF after the lecture is over. You will get the entire PDF. Don't worry about it. Now, when we talk about a bounded signal, let us talk about the meaning of a bounded signal. Okay. The meaning of a bounded signal. So my friend, what is a bounded signal? A bounded signal is nothing but a signal. Okay, a signal that has a finite height. That has a finite height, that means the peak of that signal should not touch infinity. The peak of that signal should not touch infinity, then it is said to be bounded. The signal which is finite at every point of time, at every point of time is said to be bounded signal, is said to be bounded signal. Okay, let me take an example. Let me take an example, my friend. So if you take an example of a unit step signal, a unit step signal always is either 0 or 1. This is ut versus t. So this is an example of a bounded signal. This is an example of a bounded signal. Then my friend, the other function, suppose we take a ramp function. Suppose we take a ramp function. So the ramp function keeps on increasing. RT tends to infinity as t tends to infinity, that is unbounded. So the signal whose height can reach up to infinity will be an unbounded signal, and the signal whose height is finite is called as a bounded signal. Okay, whose height is finite is called as a bounded signal. Is that clear? And guys, I can read your comments and I'll only respond to the relevant ones. Now, Karthik is asking whether it will be bounded in time or not. So Karthik, basically if a signal has a finite duration, then it is called as a time limited signal, finite duration signal, or a finite support signal. But it is not called as bounded. Bounded is related to the height of the signal. Duration, finite duration, is related to the width of the signal. So when I talk about bounded signal, I talk about the height of that signal. I talk about the height of that signal. Is this clear? Now, the next thing, what I have said in the stability criteria is that if the system produces bounded output for every bounded input, that means even if there is one bounded input for which the output can be unbounded, the system will be unstable. The system will be unstable. If you can figure out even one input which is bounded but the output is unbounded, then the system will be unstable. That means, my friend, going by this definition is very, very difficult, because we will have to check infinite set of signal which are bounded, and we have to determine whether the signal or the system produces a bounded output or not. जैसा मैंने बोला, देखो हर बाउंडेड सिग्नल के लिए आउटपुट बाउंडेड आना चाहिए, बट आप हर सिग्नल को चेक कैसे करोगे? इनफाइनाइट तरह के सिग्नल हो सकते हैं. So how can you check every signal when there are infinite possibilities? So directly going by definition is very, very difficult. We have to find an exception. Every time you will have to find an exception where the system produces unbounded output. And that process, my friend, would be difficult. So we need to make use of this definition, and we need to figure out a way to judge how can we determine if a system is stable. Vipin, you are asking bounded signal stable or not. So Vipin, my friend, signals are not stable or unstable. Systems are. ठीक है, कोई भी सिग्नल स्टेबल या अनस्टेबल नहीं होता. कौन स्टेबल अनस्टेबल होता है? सिस्टम. सिग्नल क्या होता है? बाउंडेड या अनबाउंडेड. इज दैट क्लियर? इज दैट क्लियर? So now, guys, when we are talking about a LTI system, then we very well know in a LTI system, the output of the system is determined by convolution. The output of the system is determined by convolution. So what we say? HT is basically impulse response. I think now you are very well versed with impulse response. I told you impulse response during the time response as well. Then this CT is basically RT convolution with HT. RT convolved with HT. So whenever we have a signal, we have a LTI system, we figure out the output by means of the convolution. So that is why I am writing CT is RT convolved with HT. Okay. And Siddharth, I have directly answered never a signal or a function is stable. So whoever has told you that we can judge the stability of a signal is a fool. I don't want to comment on to that. Systems are stable or unstable. Signals are only bounded or unbounded. And sine function is bounded because it always lies between 1 and -1. So that is bounded. Now my friend, how to write this convolution? Now pay attention everybody. It is R tau ht minus tau d tau. R tau ht minus tau d tau. Now my friends, what to do? What to do here? This can also be written like this. Convolution can be done in two ways. Okay. Now I will say my friend, that my signal or my input is bounded. The input being bounded means that R of t is less than equal to m for all t. Okay. R of t is less than equal to m for all t, where m is the maximum value. Like suppose if I have a sine function, the magnitude of sine is always less than 1. So this m can be 1. Suppose if I have a unit step is always less than 1. So this m can be 1. So that way m is the output, m is the maximum value of RT. M is the maximum value of RT. And my friends, I won't be able to answer all of your question. So quit posting the questions. I can't answer every question in this lecture. Okay. Because I have to take the course forward as well. Now, we apply magnitude here. So the magnitude is less than a maximum value. So my friend, what I'll now say, if you take magnitude on CT, the magnitude of CT will be this. Guys, if I take each and every doubt, then what will happen is I won't be able to teach further. I'll only be answering your doubts. Now listen to me carefully. Tell me the magnitude of it. Tell me the magnitude of it. What is the magnitude of this? Yes, the magnitude is 1. But what about this? This will be 5. Okay. So what I can say from here? Magnitude of sum is less than sum of magnitude. Is less than sum of magnitude. Magnitude of sum is less than the sum of magnitude. So integration also is indirectly nothing but sum. So this is magnitude of integration or magnitude of sum. Magnitude of sum. Magnitude of sum is always less than or equal to sum of magnitude. Sum means integration. Sum of magnitude. Is that clear? Magnitude of sum is always less than equal to sum of magnitude. So I have taken the sum in magnitude inside the sum or magnitude inside the integration. Okay. Now, mod of AB is mod of A into mod of B. Now we very well know that RT is less than equal to M for all T. That means mod of CT. If you replace RT by its maximum value, so what you can say, mod of CT will only be finite if M is a finite value, can be taken outside the integration. M can be taken outside. So you will say that it will be finite if this integration is finite. If this integration, my friend, is finite, okay, then only the output will be finite. Then only this output will be finite if this integration is finite. So what we say is, if magnitude of HT is integrable, integrable means the integration is finite. If magnitude of HT is integrable, or you say HT is absolutely integrable, HT is absolutely integrable. So condition for stability is that HT must be absolutely integrable. Okay? Absolutely integrable means the integration of the absolute value of a signal, यानी किसी वैल्यू के मैग्नीट्यूड का इंटीग्रेशन फाइनाइट आ जाए, किसी वैल्यू के मैग्नीट्यूड का इंटीग्रेशन फाइनाइट आ जाए, और यू कैन से द इंटीग्रेशन of mod of a certain function is finite, it is said to be absolutely integrable. So this criteria is basically called as Bibo stability. Bibo stability. What is this Bibo? Bibo means bounded input, bounded output. That means when the input is bounded, the output is also bounded, my friend. Bounded input, bounded output. Bibo stability criteria. Bibo stability criteria. Shreya, in discrete, this absolute integration will become absolute summation. Integration will be replaced by summation. So in discrete, you will get sigma n equal to minus infinity to infinity. Mod hn equal to finite. Integration will just be replaced by summation and ht by hn. Okay. So this is the Bibo stability criteria. There is another stability which we call as asymptotic stability. Asymptotic stability. Okay, what is this asymptotic stability, my friend? First of all, tell me what do you mean by an asymptote? So basically we say asymptote is a straight line that touches the curve at infinity. That is what we say. Asymptote is a straight line that touches the curve at infinity. So asymptotic stability says that in absence of any input, यानी जब इनपुट ना लगा हो, in absence of any input, the output must tend to 0 as t tends to infinity. यानी कि बिना इनपुट के, लिसन टू मी केयरफुली, बिना इनपुट के इवेंचुअली आउटपुट 0 हो जाना चाहिए. अगर कोई इनपुट नहीं है तो फाइनली आउटपुट क्या हो जाना चाहिए? 0. टेक एन एग्जांपल ऑफ अ फैन. सपोज यू स्विच ऑफ द फैन, सपोज यू जस्ट टर्न ऑफ द फैन, eventually the fan will stop. The fan will stop. So that is the meaning of a stable system or asymptotic stability, that if you remove the input, after a certain time the output becomes 0. Now that means this sort of a impulse response or this sort of a output, okay, without any input, the output must be somewhat like this. That means what I am saying here, that finally Ct tends to 0 if input is 0. If input is not present, finally the output will become 0. So these are the two stability criteria. One is the Bibo stability criteria and other is the asymptotic stability criteria. Bibo and asymptotic. So my friend, if we talk about stability, or let me talk about summary of what we understood after all these derivations. So what I understood is that Bibo stability criteria says that this should be finite and this asymptotic stability criteria says that Ct tends to 0 as t tends to infinity if input is removed. So these are the 2 points of stability that we have understood. These are the 2 points of stability that we have understood so far about a LTI system. Now my friend, what we have to do is we have to take both these points into control system or into Laplace transform instead of this time domain. These 2 points, whatever I have taught you, these are in time domain, right? But I want them in the Laplace domain so that I can apply the criteria onto the transfer function and I can find out the answer. Is this point clear to everybody? I want to find out what these criteria are when we map them into Laplace domain. Now, For that, let me go into the basic of the Laplace transform. I'll show you how all the signal and system is related to your control system. So what does the Laplace transform say? Laplace transform, my friend, it says that H of S is this. It is this. Okay. Now this S variable is sigma plus j omega. This is a complex number. Those who have studied Laplace before will be able to follow me. Those who have studied Laplace before will be able to follow me, my friend. And based on this S, we also define a S-plane. We also define a S-plane, my friend. This is your S-plane, where real axis is sigma and the y-axis is omega. Now, what we want is region of convergence. What I am interested in is the region of convergence. Listen to me carefully, please. What is this region of convergence? ROC. What is this region of convergence, my friend? This region of convergence means set of values of S at which HS is finite. Okay. The points at which you get a finite value of this transform is called as the region of convergence. You will say, sir, why not set of convergence? Why only region of convergence? Because that region, that area, okay, the values of S will lie on a region in a plane. They will lie in a region on a plane. On this S plane, you will get a finite area. You will get a finite area inside which those S values will lie. And an area or a surface is called as a plane. That area or the surface is called as a plane, my friend. So, basically what I will say now, listen to me very, very carefully. Mod HS. Again, I will apply the same inequality that I showed you, my friend. What inequality I showed you? That magnitude of sum is less than equal to sum of magnitude. We just now saw this. Correct? The magnitude of sum is less than the sum of magnitude. Now, my friend, when you have mod of AB, you will take it mod of A, mod of B, like this. Okay. Now, my friend, you will break it into this. E to the power minus st has been broken into e to the power minus sigma t, e to the power minus j omega t, e to the power minus j omega t. Now, that means that h of s is less than equal to minus infinity to infinity. My friend, e to the power minus j omega t magnitude is 1. Magnitude of e to the power j omega t or e to the power minus j omega t is 1 because it is cos omega t plus j sin omega t or cos omega t minus j sin omega t. So the magnitude will come out to be 1. Magnitude will come out to be 1. Now my friend, so what I'll say, if mod hs, is finite, then what does that mean? That integration of this function is also finite. Integration of this function is also finite. Now listen to me how I define. The region of convergence. How I define the region of convergence, my friend. I'll say values of sigma at which minus infinity to infinity is finite are said to lie in ROC. So that is the definition of region of convergence, that for whatever value of sigma, if you put sigma equal to 1, sigma equal to 1.5, sigma equal to 2, and you are getting this integration as finite, then that value of sigma is a part of ROC. That value of sigma, my friend, is a part of ROC. Is that okay? Is that okay, my friend? Now let us move on. So what we have obtained now, what I'll say is, what we have obtained now, we have obtained ROC is sigma such that this condition holds true, and for stability, my friend, you say that so my friend, if you compare the two equation, for ROC and for stability, you can say, sir, we can derive stability from ROC if we keep sigma equal to 0. Can you say this? That we can derive stability from ROC if we keep sigma equal to 0. Tell me, can you say this? This condition can be derived from ROC by keeping sigma equal to 0. Okay. If you can say that, my friend, then you can say that the main result is that sigma equal to 0 lies in ROC. That is the condition for stability. And this all, my friend, has been derived in signals and system. This entire concept I have taken from signals and system, where this stability comes from. Now listen to me, one more concept that I want to give you all. One more concept that I want to give you is causality. What is this causality? Causality is basically your cause and effect relationship. What is cause and effect? It says that without cause there can be no effect. ठीक है, आप लोग पढ़ रहे हो, दैट इज द इफेक्ट. क्यों पढ़ रहे हो? दैट इज द कॉज. अगर आपके पास कॉज नहीं है मेरे भाई, so you can't study without any cause. You can't study without any cause, and that is the causality. So all practical systems existing in the nature are causal. All practical systems are causal. Why? Because any system will need an input to produce an output. So what is causality? What is causality? Causality says that, it says that without cause, there can be no effect. There can be no effect. बिना किसी कारण के कोई परिणाम नहीं आ सकता. बिना किसी कारण के कोई इफेक्ट नहीं प्रोड्यूस हो सकता. So what is the condition of stability? The condition of stability is that ht is 0 for all t less than 0. That means we say ht is right-sided signal. ht, my friend, is right-sided signal that exists to the right of t equal to 0. And when we have a right-sided signal, my friend, you say ROC is right of rightmost pole. And those of my friends who are coming on this channel for the first time, make sure that you subscribe, because every day without any fail we are conducting regular classes. We are conducting 2 batches, morning Saksham batch, evening Tesla batch. So this is the Tesla batch going on for GATE 2021, and that is free of cost on this YouTube channel. So do subscribe to the channel. So my friend, now let us combine causality and stability. First of all, let me tell you how is this causality shown. Suppose we have 3 poles like this. Then you will say, sir, ROC will be right of the rightmost pole. This is the region of convergence. Then only you will say that your system is causal. That your system, my friend, will be causal. So always remember, all practical system are causal in nature. Okay, if all practical systems are causal in nature, you can say all control systems are causal, because control systems are not just conceptual system. Don't think of a control system just as a theoretical system. It is a practical system, and since it is a practical system, it has to be causal. Now if you combine causality and stability, when you combine causality and stability, my friend, then what happens? Then you say that causality says ROC, right of rightmost pole. Okay, and this says ROC includes sigma equal to 0. Sigma is the real axis. real axis or x equal to 0 implies the y-axis. Implies the y-axis. Or you can say j omega axis. So the sigma equal to 0 implies the j omega axis. So the ROC must include the j omega axis. Then only you can say the system is stable. Now I am giving you ROC. You tell me about causality and stability. I am giving you ROC. Okay. Now suppose these are the three poles. Now my friend, I am giving you 4 regions. Tell me about causality and stability of each region. Tell me about causality and stability of each region. Quickly. R1, R1, R2, R3, R4. Tell me. So R1 is to the left of the leftmost pole. If you see R1 is to the left of the leftmost pole, that is called as anti-causal. Just opposite of a causal. Anti-causal. And y-axis does not lie in R4. For stability, you have to see y-axis. For stability, check the y-axis. Whether y-axis lies in any ROC. R2. R2. Again, R2 is between these two poles. R2 is between these two poles. So it is non-causal. And again, it does not include y-axis. Unstable. R3. Again between two poles. Again between two poles. Non-causal. And it also does not include y-axis. So unstable. What about R4? R4. R4. R4 is causal. Right of the rightmost pole. But again, unstable. But again, my friend, unstable. So these ROC are all unstable, but causality we can comment. And my friend, I am seeing the likes are less than the number of viewers. Make sure that you have liked the video. Make sure that you guys are liking the video. We want to spread this initiative as much as possible. ठीक है? तो देखो कोई भी स्टेबल क्यों नहीं है, क्योंकि y एक्सिस पे पोल आ गया तो y एक्सिस कैन नॉट बी अ पार्ट ऑफ ROC. अगर यहां पोल नहीं होता तब बात अलग होती. नाउ लेट मी टेक अनदर एग्जांपल. नाउ टेल मी अबाउट दिस. Again, I am giving you 3 ROC. I am giving you, my friend, 3 ROC. R1, R2, R3. Quickly, I want answers. Quickly. Yes, Kanika, anti-causal and non-causal are different. Anti-causal is opposite of causal. Non-causal, which is neither causal nor anti-causal. Okay. So my friend, again I am asking you the same question. R1, R2, R3. What are these? R1. Again, R1 is the left of the leftmost pole. R1, left of the leftmost pole. That is why anti-causal and unstable. Why unstable? y-axis does not lie in R1. Y-axis does not lie in R1. Tell me about R2. Quickly, type in the chat section. Tell me about R2. R2 I want to know. R2 everybody, R2. R2 will be non-causal and it also does not contain y-axis, so unstable. Y-axis unstable. Tell me about R3. Everybody, R3. Quickly, responses about R3. R3 will be right of the rightmost pole, causal, and it includes j omega axis also. That is why stable. It includes j omega axis also, y-axis, so it is stable. Is it understood, Manash, or not? Quickly tell me, Manash, is this clear? So, basically why I am talking about Manash, because Manash is totally preparing from the free classes. And if he is satisfied, I believe my Tesla batch students are satisfied. So my friend, our objective was to determine the combined condition of causality and stability. Causality and stability are true together. They are true together. They are only true if all poles lie to the left of j omega axis. If all poles lie to the left of j omega axis, then this property is true. So that is the condition of control system stability. That is the condition of control system stability. Because all control systems are causal in nature. And with causal, if you want stability, then you can say that all poles should lie to the left of the y-axis. And my friends who have connected with us today itself, remember this class takes place at 7 p.m. daily. And at 5:30 p.m. Vishal sir is teaching EMFT. Okay guys, so remember how this condition has been derived. Okay my friends. Now my friends, if any of you are interested in learning with me and my team on Unacademy and want my mentorship throughout their preparation, then join Unacademy by calling on this number. Okay, join Unacademy by calling on this number and I'll make sure that you get the best rank possible. Is that clear? So my friend, download the Unacademy learning app if you want to learn control signal system, because every day from 1 p.m. to 2 p.m. I am dealing with the questions of signals and system. Then after downloading the app, click on GATE and ESE, click on get subscription. Then you can pay for this. This plan is for dropper or final year. And about final year, tonight at 10:30, I'll be discussing the 6-month strategy for final year student on this YouTube channel. And this one is for college students. But make sure that you remember the code Ankit ESE, because this code brings you directly under my mentorship, my guidance. And my friend, you can pay by credit, debit card, net banking, EMI on the debit card. Debit card EMI is also available on HDFC debit card EMI and Bajaj Finserv debit card EMI. But don't forget to use the code Ankit ESE. Okay. Now, these are some of my videos which you can watch on this channel, and these have done really well on YouTube. So you can learn how to crack GATE. And tonight at 10:30, I am coming back to discuss the strategy for a final year student. Okay, and these are the other channels that we have, like mechanical, civil, computer science, previous year questions, and SSC JE. SSC JE. SSC JE channel is for electrical, mechanical, civil.